My name is Twan Altena and I am an application engineer at De Hoek van Kerosi. What we are looking at now is one of the products which we have made with PECM. In this case, the 4 dimples that can be seen have been applied with PECM. The given product has multiple challenges which made it difficult to produce. The thickness of the material is very thin, in this case 0.4 mm. Any tension in the material would cause deformation. Besides this, a high surface quality is required with a low roughness. It needs to be produced in large quantities. That's why there needs to be a high repeatability. These challenges make this product very suitable for PECM. The first step that we take once we receive a request for a product is investigate whether we can machine the material and if all given tolerances are achievable. We can check the machinability of the material in our own database or by performing a research study. Once we know that we can machine the material, we can perform the first preliminary tests. The first test we do is mostly with a simple electrode, which is cheap and simple to make. We can also try to use an existing flow chamber in order to further reduce the costs. In the case of this product, we used a single round electrode as shown on the left picture. By machining a plate, we were able to get an understanding of how the final geometry is influenced by the shape of the electrode. We can also use this data further to optimize the flow and the shape of the electrode so that we can achieve all the given tolerances. Once the first test has been successful, we were able to design a single test electrode and a flow chamber to perform further tests on real parts. This can be seen in the right image. We use this step to optimize all conditions and get the desired results onto the final product. The most important goal of the second test is designing a flow chamber which is suitable for series production. With a flow chamber, we want to optimize the flow between the anode and the cathode so we are able to pressurize the electrolyte. By pressurizing the electrolyte, we are able to reduce the gas fraction. This increases the conductivity. On the right images, we can see the flow chamber which was designed for the test of the given product and was eventually also used for the definitive tooling. We can see the blue channels which allow the electrolyte to flow through a small opening. It then flows between the anode and the cathode, after which it can then flow outward. In this picture, we can see the definitive tool that was designed to produce the given part. We are able to machine 8 parts at once. The parts are fixed to the table on a plate. The flow chambers are pressed onto the parts, after which the electrodes can then be inserted through the flow chamber. Here we can see the electrode with flow chambers as it is turned upside down. The electrodes are seen sticking out of the flow chambers. In this picture, we can see all the tools once they are mounted into the machine. I would like to thank you for your attention and interest in the PECM technique. I will hope to see you later at De Hoek. Goodbye.